Hello everyone. In this video and in subsequent videos, we'll be discussing about theoretical probability distributions. Mainly we'll be focusing on binomial, Poisson and normal probability distributions, right? So the first one will be binomial distribution. And before we proceed into understanding about binomial distribution, we need to first understand what do we mean by a Bernoulli process, or you can also call it as Bernoulli trials. Consider a game between two persons, coin tossing experiment. So in which a particular, one person is, if head comes in a particular toss, it is considered to be a success to that person. And if tail comes, that is considered to be a failure to the same person. So among two persons, we are talking about here about one person. So if head comes, that is considered to be, let us say these persons are A and B, right? So I will say these persons, these two persons, I will consider it as A and B. Now we are focusing on person A. If person A gets head, it is considered to be his success. And if tail comes, if head comes, it is considered to be the success of A. And if tail comes, it will be considered as a success to the same person A. So in which case, the probability of his success is supposed to be 0.5 because we know it is 1/2. And naturally, the probability of failure will be again 1 minus of 0.5, which will be 0.5 only. Here, we are calling the probability of success as smaller p and probability of failure as smaller q. Now, if this particular experiment, if it is done for n repeated number of trials, this n denotes some finite number. Number of trials are finite, maybe 100 times or 50 times like that. Then what will be the objective of that particular game? In that, let us say if n is 50, means if it is 50 trials repeatedly, if he is doing this tossing of a coin, how many times he is getting heads, means how many successes are there to that person, that we may be interested. So if this is the game and if it is done for n repeated finite trials, if it is done, you call that as a Bernoulli process or a Bernoulli trials, right? So what are the assumptions considered in Bernoulli process? In a Bernoulli process, n repeated trials are performed with the following assumptions. What are those? In the experiment, there are only two mutually exclusive and collectively exhaustive events. For example, in this coin tossing experiment, getting a success or getting a failure means if I toss, if I am the person A, if I get a head, I consider that as a success to me. But if I get a tail, I consider myself it is a failure to me. So there are only two mutually exclusive events. One is success or another one is failure. Only these two events are possible. Even if we consider a die throwing experiment between two persons, suppose if I am going to ask for the number, I may ask out of 6 numbers any one number only. Means if I say 3 I want, and if I get a 3, then that is my success. If I get anything other than 3, that becomes my failure. Even though the probability of getting 3 is 1/6 and probability of getting any other number, it may not be same 1/6, but it is definitely 5/6. But still, there are only two mutually exclusive events. One is success or a failure. These are the only two mutually exclusive, and the exhaustive means these are the only events which are possible, either a success or a failure, right? The probability of occurrence of the events of the experiments are the same in all trials. Yes, if you consider a coin tossing experiment, getting a head is always 1/2. Any number of times you do a trial, it will still remain as 1/2 only. If I consider a die throwing experiment where I am asking for number 3, then every time I throw the die, the probability remains as 1/6 only for success, and for failure it remains as 5/6 only. So that is the second assumption. And then in all the n trials, the observations are independent to one another. What does it mean? It means that, for example, in the first toss, I may get a head. It doesn't mean that in the second toss, I will again get a head only. It may be tail also. Or if since I get in the first toss heads, the second toss I should get a tail. Not necessary. Means every trial, the, the observations are completely independent of each other. There is no relation between the first toss and the second toss. So that is the third assumption in a Bernoulli process. So why we need to understand the Bernoulli process and its assumptions? Because our binomial distribution, what we are going to talk about, is completely based on this Bernoulli process only. So for that reason, we have understood this is the Bernoulli process, and these are the assumptions in Bernoulli process. Right? Let us proceed. Binomial distribution. It is a discrete probability distribution. Means it takes values like this. See here, x is equal to 0, 1, 2, and so on up to n. Means it all takes integer values or integral values, and it is not continuous, and it is countable. Finite number of values. Not necessarily finite, it can be infinite also, but it is countable. 0, 1, 2, and so on up to n. N is some finite number in this particular case. So that's why you say it is a discrete probability distribution, mainly based on taking the values of the random variables. Values of random variable takes integer values. That is what is the main understanding of discrete. Right. Okay. So this is a discrete probability distribution based on whatever we had seen, Bernoulli process. Now, whatever we understood the fundamentals in Bernoulli process, based on that, the binomial probability distribution is represented as follows. What is that? Probability of, you read it as probability of a random variable x. Here, x, capital X here, capital X is a random variable, which denotes something. Maybe it denotes what you call number of heads in a tossing of a coin, or it may denote number of 3 you get in throwing a die so many times. Means I can say I throw the die for 50 times. In 50 times, how many times I'm getting a 3, number 3, right? So that I may denote it as a random variable. Basically, x can be a random variable which can be assigned with some numerical values, right? That is what it is basically. So the distribution or the function is represented as probability of capital X equal to small x is equal to NCX. What is that? It is combination. Choosing x items from available n items. That is what is NCX. How many ways you can be able to choose. Then multiplied by p to the power of x, q to the power of n minus x. And x taking the values 0, 1, 2, and so on up to n. So here, the small x is supposed to be the number of successes, and the small n is considered to be the total number of trials, whatever we are going to do. And the small p is the probability of success, and the small q is the probability of failure, right? Now, further, let's understand about the properties of binomial distribution. So, it has got n fixed identical trials. Suppose if it is 50, then each of the trial is identical very clearly, and completely they are independent to each other. That we had already seen. That is also a property. And there can be only 2 mutually exclusive events, what we said. Same thing here also. 2 outcomes, success and failure possible. And probability of success is considered to be small p. Probability of failure is considered to be small q. And we can calculate q as 1 minus of p. Now, if I add all the probabilities for all the possible outcomes, then I will get the sum as 1 only. Means the cumulative probability distribution's result starting from 0 to n will always be giving me a value 1 only. This actually x is taking a value, the summation, x is taking a value 0 to n. So NCX, p power x, q power n minus s, that is the distribution what I wrote. And that if I do it individually, that will give me a value 1. So already I wrote there, x is taking a value 0 and 1, which I wrote it here also. then the mean of a binomial distribution is considered to be n into p. Variance of a binomial distribution is considered to be n into p into q, and hence the standard deviation will be the square root of the variance, so it is square root of npq. Always remember, in a binomial distribution, the mean of the distribution will always be larger than the variance, right? So these are the properties of what do you call binomial distribution. In our subsequent video, we will do some numerical problems of binomial distribution. Till then, see you all. Please take care. In case if you find the contents of this video to be useful to you, I request you to like, share, and subscribe to my channel so that you get regular updates on my upload. Thank you.